So now we're looking at graphing a hyperbola whose center is not at the origin. So how do we do that? Well, we follow pretty much the same exact process as before, only we're not going to use a formula for the asymptotes. We're going to use the box that we were using in the previous ones. And that box is going to be from the center, which is not at the origin. So if we have the form x minus h squared divided by a squared minus y minus k squared over b squared equals 1. The center is hk. So we're asked to graph x minus 3 squared over 25 minus y minus 1 squared over 9 equals 1. So first off, notice x squared term comes first. That part's the same. We know that it opens left to right. Now we know our center is at hk, which in this case is negative 3, 1. Or excuse me, 3, 1. X minus h, h is 3. Y minus k, k is 1. We're not going to write down the center just yet because since we're not coming from the origin, we need to determine the 25 at least is a pretty big value. So we want to make sure that we have enough room to graph the actual hyperbola. We might have to change our scale. So let's look at a squared. Let's look at our vertices. And this is from the center. We know that a squared equals 25. So a equals 5. So we're going to be going plus or minus 5 from the center. So we're probably going to want to go ahead and change our scale to 2 instead of 1 in the x direction. So b squared equals 9, which means that b equals 3. So we're going to go those directions for or those amounts from our center in order to find the vertices of our hyperbola, make the box, and then draw in the asymptotes. So our vertex, our first vertex, or our center is at 3, 1. So let's go ahead and graph that. If this is 2, 3 is right about here. I think we'll be fine leaving the x scale, or the y scale rather, as 1. So let's graph 3, 1. That's right here. Now we want to go 5 to the right and 5 to the left. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So remember our center is at 3, 1. So this point over here is 8, 1. In case you have just a bigger piece of graph paper that you're using and you're using the scale of 1. And then this vertex over here is 3 minus 5, which is going to be negative 2, 1. So I mean, we can go ahead and write, I'm going to go ahead and write that over here so our graph doesn't get too busy. 8, 1 and negative 2, 1. Let me go ahead and erase all of those labels off of there. So 8, 1 and negative 2, 1. And if you want to do that algebraically, so our vertices for a squared are going to be h minus a and then k, and h plus a and then k. So in that case, in this case, that's 3 minus 5, 1, and 3 plus 5, 1, which would be 8, 1, and negative 2, 1. With B, we're going up 3 and down 3. So 1, 2, 3. 1, 2, 3. And for B squared, that's going to put us at H, K minus B, and H, K plus B, which in this case, B is 1. So our H is just going to be the same each time. 3, and then 1 minus 3 is negative 2. And 3, 1 plus 3 is 4. So now we draw in our box. It's going to look a little different than what you would expect because of the scale difference. Remember, in the x direction, it's technically twice as long as what it looks. To draw in our asymptotes, and then remember, because the x squared term is first, we know it opens left to right. So we start at our vertices and go infinitely towards those asymptotes, left and right. And if we wanted to cross our T's and dot our I's, we could look at the negative b over a is going to be negative 3 over 5. 1, 2, 3 up, and 1, 2, 3, 4, 5 over. So the slopes check out on our asymptotes, verifying that this is the correct graph for the hyperbola represented by x minus 3 squared divided by 25 minus y minus 1 squared over 9 equals 1.